Hello, today I'd like to present to you the Pendulum Worm. This was a senior design project for the Mechanical Engineering Department at St. Cloud State University, located in St. Cloud, Minnesota. This project consisted of 3 team members, myself, James Brinkman, Aaron Iverson, and Michael Anderson. The project consists of 16 mass spring oscillators, each of them operating at close to its natural frequency. The one on the far left operates at about 1.25 hertz. The one on the right here operates at 1.40 hertz. And each of them have a corresponding difference frequency of 0.01 hertz. When I oscillate them at close to their natural frequency, their amplitude will be fixed with respect to the springs here, because the springs limit their travel. Each spring oscillator is excited by a solenoid on the back side, which is just an electrical solenoid powered by a 24-volt power supply. Each solenoid is activated by a solid-state relay, which is controlled by an Arduino. An Arduino is selected for this project, especially the Omega, because it has 16 analog input pins, which allows us to vary the frequency of each mass spring oscillator as desired for that mode of operation. So today I'll be demonstrating to you the automatic mode of operation with the power supply plugged in and the power switch taken to the on position. The Arduino will power up, and you can take this mode selector switch to the automatic mode, which is the first position. Then by pressing the start button, the show will begin. With a frequency difference of 0.01 hertz from one mass spring oscillator to the next, this gives a repeat time of about 100 seconds. So every 100 seconds the show will repeat itself, essentially. Identical springs were purchased for the top, and the springs on the bottom are different than the springs on the top. Even though they are all purchased from the same manufacturer, upon arrival, the spring constant and the initial preload of each spring is slightly different, which required us to put each spring in its corresponding the maximum stretch to the minimum stretch in order to get this wave pattern. The stainless steel masses you see each of them have a different weight to achieve the desired frequency, natural frequency. Each mass consists of a stainless steel tube with an upper cap. If you remove that cap, you will expose the lead shot that's contained within those masses. And that allows you to either add or remove mass as desired to achieve the natural frequency. During the design phase, it was expected that these springs over time would fatigue, and if they did, the spring constant would change over time, which would change the natural frequency. So to analyze whether this would be a problem or not, a test stand was designed, and the springs were tested starting on January 28th at about 8:30 p.m. and were tested for 12 million cycles, which took about 4 months. And during that testing time, we found that the spring constant for the upper and lower springs did not change, which allows us to operate this Pendulum Worm for at least 2,400 hours without having to worry about recalibrating each individual mass. This project started in this project started on the first semester in the fall of 2013, and it was a 2-semester project. The Pendulum Worm finally came to life on May 5th at 10:15 p.m. 2014. And to turn the device off, just press the stop button. Thank you for watching.